Right, what's up, guys? So previously we already learned about ionic bonds. Okay, so a little bit of recap of your ionic bonds. Okay, it's basically a bond formed between metal and non-metal. All right, so how do they form ionic bonds is by donating their electron, or basically one will donate, then one will accept, and then they become ions, and then the ions are attracted by strong electrostatic forces. Hence, that bond is called an ionic bond. All right. So now we are going to go into the second type of bonding, which is what we call a covalent bond. All right. So if for ionic bond it's between metal and non-metal, for covalent bonds it's going to be between non-metals, meaning both atoms are non-metals. All right. So technically, covalent bonds will produce molecules. Okay, basically, if we say that a substance is formed from covalent bonds, we consider all them as molecules. All right, whereas for those that is ionic bonds, we call them ions. Okay, so covalent bond is through sharing of electrons. All right, between non-metals. Okay, so you need to remember that covalent bond is between non-metal. Okay, and then inside between molecules, okay, there's a type of force which is introduced in your chapter 4, if you still remember, is van der Waals forces. Right. Okay. So for ionic bonds, we call it strong electrostatic force. Okay, but for covalent bonds, the attractive force between molecules is called van der Waals forces. All right, don't worry about this. As we go into the comparison between the ionic and covalent bonds, it will be more clear. Okay, the difference between van der Waals forces and strong electrostatic forces. All right, so okay, basically your covalent bonds, since we say is for non-metals, right, meaning it will be at the right side of your periodic table, meaning from group 14 onwards. Okay, so group 14, 15, 16, and 17, all right, these elements, when you combine them, they are going to form covalent bond. Okay, group 18, remember, noble gases are not reactive, so they do not form bonds, meaning they are selfish, noble but selfish at the same time. So they do not share or they do not transfer anything to other people. They are always alone, lonely. Okay, but for group 14 to 17, all right, they are going to share their electrons in order to form a compound. All right, so it can be either between same elements or different elements. Okay, so for same elements, okay, that is why we always say that if it's hydrogen gas, the formula is H2. If chlorine, they exist as Cl2. If oxygen, they exist as O2, and nitrogen gas, they exist as N2. Okay, and the reason why they exist as diatomic, meaning 2, 2, 2, 2, because this is the most stable form, meaning they have already achieved octet or duplet in the case of hydrogen. Okay, so we are still following the octet and duplet rule, meaning if I share my electrons, I also need to make sure that I follow my octet rule. Okay, so if it's different elements, you have your water, ammonia, and also your carbon dioxide. Of course, you have more. Okay, you are going to learn later on how to explain or how to draw the formation of covalent bonds for different types of compounds. All right. Okay, so covalent bonds, basically you have three types. Okay, it's not a lot, just a little bit only. All right, covalent bonds. All right, basically you can be divided into three types. Okay, whoops. All right, so we have three types of covalent bond. Okay, first one is what we call a single bond. All right, and then second type is what we call double bond, and then finally triple bond. Okay, so three types of covalent bond: single, double, and triple bond. Okay, so what does this mean? All right, if we say single bond, meaning that the atoms, okay, they are sharing one pair of electrons. Okay, remember that one pair is equivalent to, let me use this. Oops, too big. Alright, one pair is equivalent to 2 electrons. Okay, remember that. Alright, one pair meaning 2 electrons. Okay, now if it's a double bond, meaning if you form double bond, the atoms are sharing 2 pairs of electrons. Right, 2 pairs. Alright, double bond, 2 pairs of electron. Okay, if it's triple bond, okay, your atoms are going to share 3 pairs of electrons. Okay, so that is the difference between the 3 types of covalent bond. It's just the amount of electrons that you share. Okay, it's either you share 2 electrons, or you share 4 electrons, or you share 6 electrons. Okay, so you need to remember, if we say 2 pair meaning is 4 electrons, 3 pairs is 6 electrons. Okay, I just write it out for you so that it's easy for you to see. Alright, this is 4 electrons. Okay, so remember this. Alright, and then examples, okay, will be, for example, your hydrogen gas. Okay, double bond, an example will be your oxygen. Okay, whereas for triple bond, example will be your nitrogen gas. Right, so okay, for covalent bond, for scientists or chemists, all right, if we talk about bonding between elements, right, okay, especially for covalent bond, normally we will draw it in like this. Okay, so basically the line here is telling you the type of bonding. Single bond, one line. Okay, if it's double bond, meaning I got how many lines? 2 lines. Alright, if it's triple bond, then I have 3 lines. Okay, so each of these line represents 2 electrons. Okay, so alright, so I just write down here, the key here, line here represents 2 electrons. Okay, so for a single bond, since you share one pair, right, meaning 2 electrons, so 1 line. Double bond, I share 4 electrons, so 2 lines, because each line is 2 electrons. Okay, and then if I share 3 pairs of electrons, 6 electrons, then I have 3 lines. Alright, so this is normally how we draw it in what you call, as you go into higher level chemistry, when you draw structural formulas of different type of compounds. Okay, covalent compounds. Alright, we are going to use all this notation here. Okay, single bond, double bond, triple bond. Okay, so your job is to understand the meaning of the line. Okay, each line is 2 electrons. Okay, and the way you draw it is called a single, double, or triple bond. Alright, so that is the 3 basic covalent bonds. Okay, single, double, and triple. Okay, so we are going to go into the explanation part. Alright, meaning we are going to explain how does it form H2, or why does it form O2, why not O3, and why is it N2 and not N3, so on and so forth. Okay, so here we are going to look at the different types of formation of your single, double, and triple bonds. Alright, so we are going to look into hydrogen molecule first. Okay, so hydrogen atom, remember the proton number is 1, right? So they only have 1 electron. Okay, so for hydrogen atom, in order to become stable, they must achieve duplet. Okay, because hydrogen can only achieve duplet. Alright, octet is for other elements. Okay, since they only have 1 shell and the first shell maximum is 2 electrons, that is why they achieve duplet. Okay, but how do they achieve duplet? Okay, is by sharing electrons. So basically the idea is like this. 2 hydrogen atoms, each of the atom will contribute 1 electrons for sharing. Okay, so if you look at the sentence here, right, 2 hydrogen atoms share a pair of electrons to form hydrogen molecule. Okay, and then both atoms will achieve stable duplet. Alright, so if we were to draw the electron arrangement, okay, so I have hydrogen atoms, two hydrogen atoms. Alright, so I have H here, H here. Okay, so I have one electron here, and then like this. So what they are going to do is basically they are going to share. Alright, so each atom will contribute one electron for sharing. Okay, so when we draw the sharing of what they call or when you draw the electron arrangement for covalent compound, it's different from your ions. Remember, ions we put a bracket and then we put the charge, right? Now in case of covalents, it's different because they do not form ion. Okay, so if share, meaning I'm going to combine the two shells together. Okay, since we say they share, right? So draw a big one like this and then share electrons. Okay, so basically they are okay. Alright, this is what we call as sharing. Okay, so both shells combine together and then the electrons we draw it in the middle here. Alright, so this is the hydrogen molecule. Okay, your H2. Right, that is how we draw the electron arrangements for covalent compounds. Okay, so your hydrogen, for the blue hydrogen atom here, they have two electrons, so already achieve duplet. The red hydrogen atom also have two electrons now. Okay, so also already achieve duplet, so this is stable. Okay, so basically they are sharing one pair of electrons, right? Therefore they form a single bond. Okay, so that's why this one, if we draw in the what they call using the line, then they will become like this, each one line like that. Okay, so this one line represents the electrons shared here. Okay, all right. If we were to use the what they call a Lewis structure to draw this, okay, so Lewis structure, remember we only draw the valence electron. So I have H and then the valence electron. Okay, we don't need to draw the shell, right? H valence electron. Okay, so if we use the Lewis structure, we can actually see how we can share the electrons. Okay, so basically you just combine the two. All right, so you will have H like this. Alright, so this is also equivalent to this one. Okay, so basically you just combine the two things. Okay, so this is your H2 molecule, hydrogen molecule. Right, this is how we draw it if we use the Lewis structure. Okay, remember this is Lewis structure. Okay, and then okay, this is electron arrangement. Okay, so that is the formation of your hydrogen molecules, single bond. Alright, next. Okay, oxygen molecules. Okay, we already know that oxygen molecule is an example of double bond. But how do they share their electrons? Alright, okay, so oxygen atom is 2,6. So basically they need two more to achieve what they call octet, right? Okay, so how can they do this? Alright, so two oxygen atoms will share two pairs of electrons, okay, to achieve stable octet electron arrangement. Alright, so basically each oxygen atom, okay, each oxygen atom will achieve stable octet electron arrangement after they share their electrons. Okay, so how do they share? Now, normally, we will use the Lewis structure to see how to share electrons. It's easier, alright, before you draw the electron arrangement. Okay, I will always suggest my students to use the Lewis structure to identify how do we share the electrons. Okay, so let's say I have one oxygen atom here. Alright, so 2, 4, and then 6, right? Okay, right, another oxygen atom. Okay, so 2, 4, 6. Okay, oh, and another thing is, the reason why I'm using dot and cross is because I want to differentiate between two different atoms. Okay, in your SPM exam, there's no law saying that it must be cross and dot. There's no such thing, all right? But it will be actually easier for us to identify or to prevent us from getting confused if you use cross and dot, so that you know that the electrons comes from which atom. Okay, especially in terms of the ionic bonding. All right. Okay, so here, oxygen atom 246. I need two more electrons here. Okay, so we need to figure out how to arrange so that both will get 8 electrons. Now, maybe some of you, because you see there's an empty 2 space here, right? So what you will do is you're going to do this. You say, okay lah, just take this, and then we just combine here like this. And then you say, okay, done, share electrons, finished. Alright, but the problem is, if you were to calculate the what do you call electrons surrounding the atom, right, you will notice that the blue one, 1, 2, 3, 4, 5, 6, 7, 8, correct? The blue one has already achieved 8 electrons, already achieved octet stability. But the red one, 1, 2, 3, 4, 5, 6. Okay, you're still lacking 2 electrons, not enough. Alright, so this arrangement is wrong, cannot work. Okay, so we need to try another type of arrangement. Okay, so this one, okay, we need to try again. Okay, so but since we already say that they are going to share 2 pairs of electrons, right? Meaning they are going to share 4 electrons. Okay, 4 electrons. So what we are going to do is very simple. All right. Okay, we are just going to take this thing, straight away combine it like this. Okay, so in other words, if you were to draw it in the what do you call Lewis structure form, all right. So 1, 2, 3, 4, 5, 6, and then so if you were to have the red oxygen atom, too far. So if you were to have the red oxygen atom combined in the middle right here, all right. So 2, 4. Okay, so this part in the middle here shows you the sharing of the electrons. Okay, so the total amount of electrons shared in the middle here is 4. 1, 2, 3, 4. Okay, so every time when you combine different arrangement, you always check for each atom to see whether they have a total of 8 electrons. So we are going to calculate oxygen atom 1, 2, 3, 4, 5, 6, 7, 8. So this maximum, done. Okay, the red one, all right, 1, 2, 3, 4, 5, 6, 7, 8. So both have 8 electrons. Okay, so since both have 8 electrons, all right, meaning that they are already stable. Okay, that is why your oxygen molecule exists as O2. All right, but or if you use the line to denote, it will be 2 lines like this. Okay, O double bond to O. Okay, so that is if we use the Lewis structure. All right, so if we were to draw the electron arrangement, okay, so how do we draw this? So 2, 6, right? So 2 shells. Okay, and then this is also 2 shells. Right, so oxygen here. So 2, 4, 6. Okay, and then this one. Oh, I have it. This is dot. Okay, 2, 4. Right. Okay, so they are going to share. Alright, remember you always use the word share. Okay, so share their electrons. So we are going to combine their shells. Draw the big shell first. Okay. Alright. Okay. Alright, so we have 1, 2, 3, 4, 5, 6, and then we have the oxygen here. 2, 3, 4, 5, 6. Okay, so in the middle, how do we draw this? Cross. So basically, we're just going to do alternate cross, dot, cross, dot. Okay, so this is your oxygen molecule, O2. Alright, sharing of 4 electrons in the middle, 2 pairs of electrons. Okay, so every time after you do this, you just calculate and check. Okay, 2, 4, 6, 8, done. 2, 4, 6, 8, done. Right, so that is for oxygen molecule. Okay, so number of electron pairs shared is 2 pairs. Okay, that's why you form double bond. Alright, now for nitrogen molecule, okay, nitrogen is group 15, right? So basically their what we call valence electron is 5. So meaning I have 1, 2, 3, 4, 5. Okay, another one, 3, 4, 5. Okay, so how can we share the electrons so that both of the nitrogens will get 8 electrons? Okay, so I need 3 electrons, right? So if I need 3 electrons, meaning we are going to share 3 electrons. So when you reach this point, you will start to see the relationship. Okay, so I'm just going to draw you how we share 3 electrons. Okay, 1, 2, 3. And then nitrogen beside. Oops, so become red. Nitrogen, alright. So 1, 2, 3. Okay, so this is the triple bond here. Alright, this is how we get this. 1, 2, 3. 3 lines here. Right, so remember we check our electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Done. 1, 2, 3, 4, 5, 6, 7, 8. That is how you get your triple bond. Okay, so when you reach this point, you will start to see a relationship. Okay, into how do we know that they form single, double, or covalent? It depends on how many electrons they need for sharing. Okay, so if you see in this case here, right, we know that they are going to form covalent bonds. All right, and I know that there are 5 valence electrons. They need 3 more electrons to achieve octet, right? So if they need 3 more electrons, they are going to share 3 pairs of electrons. Then they are going to form triple bond. Okay, and then oxygen, if you see, I need 2 electrons, right, to achieve octet. So they are going to share 2 pairs of electrons. So they form double bond. Okay, and then single bond, I only need 1 electron, right? Okay, so if I need 1 electron, I'm going to share 1 pair. So that is the idea of your covalent bond. How many electrons you need will determine the type of bonding you will form. You need 2 electrons, you form double bond. If you need 3 electrons for sharing, you will form triple bond. That's it. Okay, very simple, right? Okay, so nitrogen atoms with an electron arrangement needs 3 electrons to achieve stable octet. Okay, so they are going to share 3 pairs. Okay, so you see the relationship needs 3 electrons, so you share 3 pairs of electrons. Okay, to achieve stable octet. Alright, to form nitrogen molecule. Okay, remember covalent bond, we are always going to form molecule. So niche, okay, same thing again. Alright, so draw electron arrangement. Okay, the most troublesome part is to draw electron arrangement. Alright, so I'm going to draw your nitrogen atoms. 2, 5. Okay, so and alright. Okay, so 2, 1, 2, 3, 4, 5. Okay, this one is okay, and then we always show this. Okay, share. Okay, so how do they share electrons? So, okay, so draw the big one first. Okay, so it's easier later. Like that. Okay, then only draw in the middle. right? So this one is nitrogen, so 2, and then I have 4 here, right? 2, 4, and then nitrogen here, 1, 2, 1, 2, okay, and then we're going to go alternate, 1, 2, 3, alright, 1, 2, 3. Okay, so in total you are going to have 6 electrons in the middle. Okay, so this is the molecule for your nitrogen gas. Alright, okay, so you share 3 pair, you form triple bond. Okay, so that is how you determine the type of bondings in covalent compound. You determine first how many electrons they need to share between the atoms. Okay, so how do we do that? You draw out the Lewis structure, and then it will be easier for you to see. Alright, so I'm going to show you one example like this. Okay, where it's for different type of elements. Okay, hydrogen chloride molecule. Okay, so predict the formula, right? So you know your electron arrangement here. This is 287, right? Okay, so this fella needs 1. This fella also needs 1. So the amount of electrons that you need for sharing is 1, right? So if I were to draw the what they call Lewis structure, this one, and then this is 1, 2, 3, 4, 5, 6, 7. Alright, so I need one more here to achieve octet for chlorine. I need one more here for hydrogen to achieve duplet. Correct? So the amount of electrons that you need is 1, right? So you are going to share 1 pair of electrons. That's why this is going to form a single bond. Okay, meaning it's going to become like this. Hydrogen, then your chlorine. 3, 4, 5, 6. So you see in the middle here, you're only sharing 1 pair of electrons. So they form a single bond. Okay, so basically that is how you are able to identify the type of bondings between different elements in covalent bond. You check and see how many electrons they need. If both need 1 electron, they are going to form a single bond. Okay, meaning they are going to share only 1 pair of electrons. If both needs 2 electrons, they are going to share 2 pairs of electrons. Alright, so I'm basically repeating this like a parrot again and again and again. Okay, but this one is to actually help you to understand lah. Alright, and then you just draw the electron arrangement. So let us draw. Okay, hydrogen, 1 shell here, cross, and then chlorine I have 2, well, 3 shells. Okay, so 2, so 2, 4, 6, 7. Okay, and then share. Alright, so your hydrogen, okay, and then your chlorine. Okay, so 2, 4, 6, 8, 2, 3, 4, 5, 6, okay, 7. Okay, your hydrogen 8. So this is your ACl. Okay, this is the electron arrangement for this particular compound. Alright, so make sure you draw correctly. Okay, so let's look at the explanation. Let's see how they explain the formation of the bond. Alright, so it's almost similar to your ionic bond. So you need to explain for both atoms. Alright, so hydrogen atom. Oh man. Alright, atom with electron arrangement needs 1 electron to achieve stable. Okay, remember hydrogen they achieve duplet, not octet. Alright, but chlorine, okay, needs 1 electron to achieve octet. Okay, so this part is important, yeah. All right, so one chlorine atom will share one pair of electrons with one hydrogen atom to form hydrogen chloride molecule. Okay, remember for covalent bond you always form molecule. Okay, so each chlorine atom, or we can also say one chlorine atom contributes one electron and one hydrogen atom contributes one electron for sharing. Okay, so normally your explanation, right, will include this part here, D here. Okay, we will need to mention each atom contributes how many electrons. Okay, alright, for your exam you always need to write out this one. Okay, for each atom. Okay, so one chlorine atom forms single covalent bond with one hydrogen atom. Alright, you form one single covalent bond. Okay, the meaning of one single covalent bond meaning that inside here you only see one line lah. Okay, can we have different single covalent bond? Can. Let me just show you for one example here. Okay, so as you can see, all these are single bonds. Okay, just that I have four single bonds here. Okay, 1, 2, 3, 4, four single bonds. Right? Can you have more than one double bond? Can. Everything also can. Your carbon dioxide. So as you can see here, your CO2, right, your carbon dioxide, they form double bond. But how many double bonds do they have? They have two double bonds. Okay, so it's not always only one. It can be more than one. You can have four single bonds, you can have two single bonds, you can have three single bonds. Just understand that if we say four single bonds, meaning we draw it like this. One line, one line, one line. Okay, two double bonds, okay, we draw it like this. Okay, or if let's say we say they form four double bonds, right? So for example, this one like this, then maybe this one like this. Okay, so this is four double bonds. Okay, so I hope you understand the meaning. Alright. Okay, so chlorine atom achieves stable octet and hydrogen atom achieves stable duplet. Alright, okay, don't worry. So later on, I will teach you guys how to write a more proper answer for your SPM questions. Okay, the proper, what they call a more simplified version of this explanation. Okay, alright, so that is the formation of your covalent bonds. Okay, that is it. Alright, so to my students, okay, you can try and work out for your water molecule. Okay, so determine, alright, how many bonds you need to share between the hydrogen and the oxygen. Okay, I'm sure I'm going to get very creative answers here. Alright, just give you a hint. Okay, hydrogen, right? Oxygen. Okay, now my hint to you is this. You need to remember that one hydrogen atom can only contribute one electron. How many do I need here? Okay, so try and relate, yeah? Alright. So I believe that is it for today, your covalent bonds. Okay, so once you have already completed the ionic and the covalent bonds, then only I will teach you the difference between the two. Okay, the comparison between your ionic and covalent bonds. Okay, what are the main differences between these two types of bonding? Alright, but that is it for today. Okay, see you again next time. Bye.